Hello, everyone, and welcome to this course on reasoning based large language models from scratch. We are incredibly excited to launch this course and to be able to provide this knowledge to all of you. So, before we get started, I would like to introduce myself. My name is Dr. Rajat Dandekar, and I will be your instructor for this course. This is the first course that I am teaching. As a part of our YouTube channel. You might get me confused with Dr. Raj, who has taught courses like building your LLM from scratch, uh, or ML teach by doing, or build neural networks from scratch. I am his twin brother. Don't confuse me with him. Okay, so a bit about myself. I have done my BTech and MTech from IIT Madras, and after that, I did my PhD from Purdue University in the US. I have always been a very passionate teacher and educator. In fact, during my college days, there were a lot of friends and people who advised me that you teach concepts very well. Why don't you become a teacher? But I was very passionate to do research at that time. So I went ahead and did my PhD. And then after all, uh, my calling came after me, and uh, I, I I co-founded Vijwara along with Raj and Sridhar, and now we have this mission to make artificial intelligence accessible to everyone. And it gives me immense pleasure to be able to teach this course to all of you. Uh, okay, that is enough about me. Let's dive into the course details for now. So, if you have stumbled upon this video, the one thing I can guarantee you is that you will be able to follow every single thing that I'm teaching in all the videos that follow without any prior knowledge. So, my teaching style is based on two quotes. The first quote is that if I'm not able to teach a group of beginners about a subject, then I myself have not understood the subject, and I take this very, very seriously. And the second is that I try to make the subject as simple as possible. These quotes might be inspired from other people, but for now I'm taking the liberty to attribute them to me. Uh, okay, so this is going to be the teaching style. We are going to explain all the concepts, everything from scratch in every single video. And I am going to make sure that whatever I teach, so let's say I'm teaching a concept X, then I'm not using the word X in my explanation because that defeats the whole purpose. Okay, now let us get started. Let us understand what this course is all about and why are we talking about reasoning based LLMs right now. So, firstly, human beings like all of us have this incredible power of being able to think deeply about a subject. Let's say you're ordering a cake for your mother on her birthday. There are a lot of things that you think about. First is, what is her favorite cake? Should I try something different this time? What was her reaction last time to the cake which I had ordered? Did she like it? Did she not like it? Has something changed in the last year? Has she developed dislike towards any particular flavor, etc.? Has she expressed any recent cravings for that matter? There are a series of thoughts which go on in our brains, and the interesting part is that all of these thoughts happen in a very, very small fraction of time. That is, they happen extremely fast. So, this is what I'm calling as thinking deeply. Uh, there are a series of thoughts which run through our minds whenever we are making a decision, which is what we call as thinking. Now, this is what we call as reasoning or thinking, and we say that human beings have the power to reason. Now, if you think about reasoning, reasoning comes in two types. There is a fast type of reasoning and there is a slow type of reasoning, which is also called as system 1 reasoning or system 2 reasoning. What is system 1 reasoning? System 1 helps us think immediately for an answer. You can see from this image that it constitutes almost 95% of our brain. This is system 1. So, for example, if I ask you the question, what is the capital of India? The answer just comes naturally to us because it is driven by two things. It is driven by our intuition, all our past experiences, etc., and our instincts. So, system 1 accounts for 95% of our entire thinking process. System 2 is where we take time to think about a subject. It takes effort for us to think, and this is the system which is slow, logical, lazy, and indecisive. For example, let's say I want to go home tonight after this recording is over, and I want to watch a movie. Now, there are a lot of things I need to consider: which genre, which OTT platform, are there any recent releases, what are the reviews on Rotten Tomatoes, how have people reviewed it, etc. What are the IMDb reviews? There are so many things that are coming in my mind right now that I'm not even able to make a very fast decision. This is the type of question which comes under system 2, where you take your time and you think about the question in a very slow and deliberate way. Now, the central question which a lot of people, everyone in the AI community is interested is, can artificial intelligence reason? So maybe you think, yeah, it should reason, right? Isn't AI made to think like humans? Well, the answer is no. AI is not made to think like humans. AI is made to answer like humans. Have a look at the first version of ChatGPT, which came out in November 2022. It was able to answer questions very fast. For example, here you can see, because it was made to answer like humans. But if you ask me the question, did ChatGPT 3.5 reason, then I am not sure, right? Where is the reasoning here? You directly get the answer. You do not get the step by step process by which ChatGPT 3.5 is actually thinking. So ChatGPT 3.5 was crazy good on tasks. So let me rephrase this. It was crazy good on system 1 type of tasks. So ChatGPT 3.5 was crazy good on tasks, which was system 1 kind of tasks. That is, tasks which required fast and immediate answers. For complex tasks which required reasoning, like solving puzzles, thinking, and planning, it was not very good. Uh, so, from this figure, we can see that ChatGPT 3.5 was good in System 1 type of thinking, but it did not display any signs where it could actually reason. It could actually think about the question and give you the answer. So, as a user, I could see that I'm getting an answer, but I'm not sure if ChatGPT has really understood the problem or not. And one manifestation of this was that ChatGPT 3.5 hallucinated a lot, which means that sometimes it used to give very random answers which did not make any kind of sense. Now, if you have actually understood the question or if you are reasoning, then you will never give such random answers, which was the first sign that okay, this was an AI which was made to answer like humans, but it was not made to reason or think like humans. But we did not give up. The research continued to develop, and the first reasoning model O1 was released by OpenAI on September 12, 2024. Now, here I have asked it the exactly same question which I had referenced before: which movie shall I watch tonight? And you can see here that it says reasoned about movie recommendation for a couple of seconds, and at the bottom also you can see uh, ChatGPT O1 says that I'm thinking through a variety of comedic styles for the user. Options span witty, dramedy, action, classic, etc. So This means that from ChatGPT 3.5, we went to a version uh, where the oven model could actually reason. It could think about the question that I was asking, and it could give an answer where I could see the thinking process in the background. So imagine that you are representing a healthcare company or a pharma company or a finance company, and you have delivered an application to your clients, uh, which is a very high stakes applications, which is actually going to impact lives of people. Whenever you are delivering such an application, and let's say you have a large language model like ChatGPT running in the background, would you prefer directly giving an answer to the client, or would you prefer showing the client the step by step reasoning process which has got the LLM to that specific answer? The second case is where the clients will trust your application much more. And this is the power of reasoning models. That is why everyone is interested in reasoning models right now. You don't directly want an answer. No. What you want is you want to see the thinking process behind that answer. And since then, the progress in this field has been tremendous. Another huge breakthrough was at the start of this year, where DeepSeek, which is a Chinese company, they released a reasoning model which they named as DeepSeek R1. And this completely stunned the world. But okay, you might think that O1 was already released, right? So why did it stun the world? The first reasoning model was already released by OpenAI. What was so special of DeepSeek? What was so special in DeepSeek R1? So there were three things mainly. First was that it was completely open source. OpenAI has not revealed the architecture of any of their models, but this is the first time we get a glimpse of a model which works with an accuracy that is comparable to O1. Okay, so accuracy was comparable to O1, and we could finally see the architecture which DeepSeek used, which then we probably tried to backtrack saying that okay, so this works well at reasoning, which means that maybe O1 also has a similar architecture. uh, and then one of the major breakthroughs in this was that it achieved reasoning by pure reinforcement learning. You will start to appreciate this much more as we dive into the course later, but this was a tremendous breakthrough, and they in fact write it over here. This was the technical report which was released by DeepSeek, and I want you to focus your attention over here. You can see that DeepSeek was given a question which says if a is greater than 1, then some of the real solutions of square root of a minus square root of a plus x equal to x is equal to what? Now in the middle of the analysis, DeepSeek rethinks its analysis. It says, wait, that's an aha moment I can flag here. Let's reevaluate this step by step to identify if the correct sum can be. And this is termed as the occurrence of an aha moment. This truly demonstrated the power and beauty of reinforcement learning, as they say right over here. So, I will explain this in detail later. Don't worry about RL right now. But just to give a very brief understanding, what this meant was that uh, for the first time, a large language model could learn to reason without explicitly prompting it to do so, but only by giving a reward. The model could learn that reasoning is the only way I can get from where I am right now to the place where the reward is the maximum. So it was a very natural way that the model learned to reason. And I think this is one of the biggest breakthroughs of uh, in the AI field, in the large language models field. And reinforcement learning is such a beautiful subject that all of you will begin to truly appreciate it as we go through the course. Okay, so Okay, so all of this is about reasoning. What is reasoning? Why is reasoning important? In this course, what we will learn is that we will learn to give reasoning powers to a large language model. I have not defined large language models before. So, large language models are uh, any, let's say, model or an application where you are giving an input and the model is predicting the next word with the maximum probability and giving you the output. So most common examples are ChatGPT, uh, all the versions, then Cloud, Gemini, DeepSeek. There are a lot of large language models, but you will see me using this term quite often during this series. If you don't understand what LLMs mean, simply think of them as a replacement word for ChatGPT as of now. That would be completely fine. So in this course, what we'll be learning is that we will. So this is the pipeline or the flow for a regular LLM, where you ask a question, it goes through the LLM, and finally it gives you the answer. But in the reasoning LLM, what we see is that we also show the sequence of thoughts which lead to the answer. In this course, we will learn to give reasoning powers to LLM. That is, we will take the LLM from this diagram to this diagram. So this is, in a nutshell, what we are trying to do in this course. Now, let's try to understand what all is available on the internet. Uh, I would like to state that the year 2025 is, I think, the year for reasoning models. This is the hottest field right now. Just last week, a company in India, Fractal Analytics, they proposed to develop a first LRM model. What is an LRM model? It's a large reasoning model. India's first large reasoning model under the India AI mission. So reasoning models are getting more and more popular, and I was also interested to see what are the type of courses out there, and what kind of analysis have people done on the internet. So if you look at the YouTube results, you can see that about reasoning there are probably some tutorials which are 10 to 30 minutes long. So this is explaining OpenAI's own reasoning models, which is 27 minutes, understanding and effectively using AI reasoning models 15 minutes, reasoning models 10 minutes. So all of these are very short videos, and even though you will get when you see these videos, you will understand the terms which are used in the community. But if someone actually maybe grills you with the topics, uh, mm, or probes you more deeply, you will not be able to answer them. And I believe that you will truly understand this subject if you know all the terms completely from scratch. And such a course does not exist anywhere on the internet. That's the reason our team and me, we have taken a lot of efforts to make this course and make it accessible for all of you. A simple LinkedIn search will reveal a lot of articles on reasoning LLMs. You can see that a lot of people are also building reasoning based LLMs for production, etc. And the reason is that the application or the practicality of reasoning LLMs is so high that it makes complete sense to transform an existing LLM into a reasoning LLM. For the reasons I explained before, it makes your model much more trustworthy if you understand the thinking process which an LLM goes through. Okay. Okay. So now let's go deeper, and in the next section of this video, we will understand about the course structure and the exact content that we plan to cover. So, the name of this course is Reasoning Based LLMs from Scratch. And here, by reasoning, we mean something very specific. When I say reasoning, I mean that the process of answering questions which require complex multi step reasoning with intermediate steps. Now, I do understand that I have used the word reasoning in my definition, so please ignore that. But I hope you understand what I'm trying to say. Let me clarify through an example. Let's say you ask this question to a large language model: if a train is moving at 60 miles per hour and travels for 3 hours, how far did the train go? The plain response from a regular LLM would be the train travels 60 into 3, which is 180 miles. All of us did the same calculations in our mind. But a reasoning LLM would give the response something like this. To determine the distance traveled, we use the formula distance is equal to speed into time. Given that the speed is 60 miles per hour and the time is 3 hours, distance is 60 into 3, which is 180 miles. So the train is traveling a distance of 180 miles. This is what we mean by reasoning. Okay, so please understand this definition, because I'm going to use the word reasoning a lot in the remainder of the course. And whenever you hear me saying the word reasoning, you should refer to this example. If the LLMs can do this, we say that the LLM has reasoning powers. Now, whether the large language model can actually think, that is a separate question. No one knows the answer to that. We are still trying to find out. But here, we are not thinking about that. We are simply talking about reasoning with a very specific definition. The course will be divided into four main modules, which I will explain now step by step. And I want you to understand these modules at a broader level in this video so that you appreciate how we are giving reasoning to a large language model. Okay, so we will start from module 1 and we will go to module 4. At any time, if you feel like you are getting distracted or your focus levels are not uh, the same as they were before, please stop the video, because I want you to understand uh, the different modules without having any doubts. Okay, so the first module, which is module number 1, is called as inference time compute scaling. We will understand what this means now. Okay, so firstly, let us think about humans. Humans give better answers when they think for more time. Why? Because thinking step by step leads to a correct answer. Take some examples. Let's say you're solving a puzzle, maybe Sudoku or a crossword puzzle. Now, whenever you're solving a crossword puzzle, there are multiple puzzles in the horizontal line and there are multiple puzzles in the vertical line. Let's take an example to understand this. Let us take an example of Sudoku. So Sudoku is an example of a game where you have to fill numbers based on a predefined set of rules. Now, it is very hard to directly start filling numbers in these blank spaces. And the right approach is that you have to think from multiple angles. So it's a problem in which if you think for more time, you will get better answers. This is common with all problems which require complex reasoning. Uh, Another problem I can think of is, are there finite number of prime numbers or there are infinite number of prime numbers? This is also not a very easy problem, but the more we think about it, the better we'll get to the answer. Okay. Uh, think about it in a similar way. When you were small, you're writing an exam. Uh, you used to ask to your teacher that, ma'am, I need more time to write. I'm simply not being able to finish the exam in this time. Why? Because more time meant that you could think more and probably you could get better answers. When we think more, we use more of our mental energy. Now, the question is that what will happen if we make LLMs think more before giving an answer, right? So, let us take a simple example. Uh, the example that we are going to consider is Roger has five tennis balls. He buys two more cans of tennis balls. Each can has three balls. How many tennis balls does he have now? Quickly do this calculation in your mind. Now, let's look at a regular LLM which does not reason. When you pass this prompt to a regular LLM, you get an answer which says answer is 11. The total number of tokens which the model uses to give the answer is 3. First is answer, second is, and the third is 11. So this is the first token, this is the second token, and this is the third token. So the model is using 3 tokens to give you the answer. Now let's force the model to think before it gives an answer. So what do I mean by think? First, the model says that Roger started with 5 balls. Okay. Then the model says that 2 cans of 3 tennis balls, each is 6 tennis balls. So 5 plus 6 is equal to 11. And finally, the answer is 11. So now, how many tokens is the model using before it gives you an answer? It is 4 plus 11 plus 5 plus 3. That is a total of 23 tokens. Okay, so in the regular LLM, the model is using 3 tokens. But if you ask the model to think before it gives an answer, then it requires 23 tokens to answer the question. So you are going from the number 3 to the number 23, right? So now let us come to a definition which is called as test time compute. Test time compute is the number of computing resources used by the model during inference. Okay, so this process of giving the answer is what we call as inference. So now, with this definition, can you tell me in which case is the test time compute more? In the second case, the model is using 23 tokens, which means that it is using more computing resources to generate an answer, which means the test time compute or the inference time compute in the second case is almost 7 to 8 times more than the first case. So there are two words or two definitions or two new words I have introduced here. First is test time compute, second is inference. Test time compute is the number of computing resources which the model is using during test time, and inference is uh, the large language model is trained, which is fine. You are not disturbing that anywhere. But after the training, the process which leads the model to give you an answer, that is called as inference. It is very similar to when I am preparing for an exam. The preparation stage is called as the training stage. But when I am actually giving the exam, when I am writing the answer, that is the inference stage. So that is the meaning of inference. Okay, so now what people have found out is that the first method to induce reasoning in a model is the first method to induce reasoning in a model is to spend more computational resources during inference. We do not change anything in the model at all. The only thing we change is we allot more computing resources in the inference, which is what you see here. This is very less computing resources, and this is more computing resources. So what people have found out is that if you allocate more computing resources during inference, then the model can reason, the model generates reasoning. Is this intuitive at all, or this is not intuitive? Think about the first example which I gave before. What did we understand here? If we think more deeply about a concept or a topic, we tend to give better answers. Exactly same is true for a large language model. If you give more time during the inference, then the model gets time to think more and it generates a better answer. Now, this is what people have seen, that if you increase the test time compute, generally the accuracy of the model also goes up with the test time compute. So we also say that the model accuracy scales with the test time compute. That is why the name is inference time compute scaling. Okay, so let us understand this one more time in a better way. Essentially, uh, it all started with the thought process that when humans think more uh, before giving an answer, then they tend to give better answers. So, if you allot more computation resources to a large language model during inference, then it will give better answers, and it will also show you the series of steps which leads to the answer, which is called as reasoning. People also saw that more number of computation resources increase the accuracy. That's why the name is inference time compute scaling. If you take time to process this, just pause and just reflect on what I said. It's a very interesting and straightforward concept to understand. Now, okay, so let's go ahead. This sounds very intuitive. When did we think of this first? The first paper which came out in using this method was in the year 2022 by the brain team at Google Research, where they introduced a method called chain of thought prompting. So, what did they do? What they did was they started to prompt the model. So this is what is called as prompting. We have taken the same example as before. Roger has five tennis balls. He buys two more cans of tennis balls. Each can has three tennis balls. How many tennis balls does he have now? Now, this is what they provide as a model input. That is, they are telling the large language model that whenever you have you have been asked with a question like this is what you can start to think about. So it says Roger started with five balls, two cans of three tennis balls, each is six tennis balls. Five plus six equal to 11. The answer is 11. This is called as prompting. Now, the moment you prompt this, if I ask another question, which is a new question, that the cafeteria has 23 apples. If they used 20 to make lunch and brought 6 more, how many apples do they have now? So you can see that the model starts to answer in a very similar fashion. It says the cafeteria has 23 apples originally. They used 20 to make lunch, so they had 23 minus 20, which is equal to 3. They bought 6 more apples, so they have 3 plus 6 equal to 9. So the answer is 9. What did we see here? If we teach the model with this set of prompt, this is called as chain of thought. We don't tell the model to directly come up with an answer. So standard prompting is where the model directly comes up with an answer. But it makes a mistake here, see. So chain of thought prompting is where we tell the model that don't give me the answer directly. But before you give me the answer, you show me the chain of thought before the answer is given. And then the moment you do this a for a few set of prompts, the model learns how to do it for new set of prompts also, which the user is giving. This is called as chain of thought prompting. Now, why does this come in this category of inference time computing? The first thing is that we are not changing anything with the model itself. We are not fine tuning the model, we are not training the model again. No, all we are doing is that we are changing the answer which is given by the model during inference stage. And how we are changing that? We are using a technique called as chain of thought prompting. So this is one example where you can induce reasoning in the model during inference without affecting anything in the pre-training and the fine-tuning stage. I know I have utilized words like pre-training and fine-tuning here. Don't worry about them. And by the way, we'll understand about chain of thought in complete detail when we come to that section. Okay, so since then, there have been several methods which have introduced reasoning only during inference without tweaking anything in the model. And generally, there are two categories of test time compute, which is the first category is called prompting, which is what we saw before. It was a case of prompt engineering. We carefully engineer the prompt so that we get the answer which looks like the model is reasoning. And the second is verifiers. I will explain verifiers when we come to this section in complete detail. So, this is the first method, which is inducing reasoning during inference. One example that we saw here was chain of thought prompting. The technique was developed in 2022. After that, we have seen a lot of progress here. We have gone to zero shot prompting, tree of thought prompting, and there is also a section on verifiers, which will be covered in this section. The main concept here is that you allot more computing resources to the model during inference stage so that the model learns to reason. How does it learn to reason? Either through clever prompting or through verifiers, which we will see when we cover this module in complete detail. Now, let us go to the next section, which is pure reinforcement learning. DeepSeek R1 showed in their technical report that in the intermediate version of DeepSeek R10, the model learned to rethink using pure reinforcement learning. This is what is the output which is given by the model. So we ask a mathematical question at the top right, and it starts to give an answer in the initial part, which is over here. Then it suddenly realizes that, okay, maybe what I'm doing is not correct. And it says that, wait, that's an aha moment I can flag here. Let us reevaluate this step by step to identify if the correct sum can be. So this is the section which is highlighted in red in this paper, and this was one of the major breakthroughs in the reasoning literature. Why was this one of the major breakthroughs? The reason it was one of the major breakthroughs is that the model learned to reason without giving an explicit prompt. In the previous method, what we saw that in the chain of thought prompting, for example, you are modifying the prompt itself. That is why the model is giving you a bunch of reasoning steps. But in pure reinforcement learning, we are not modifying the prompt, but using a set of reward functions, we are asking the model to learn the right way of reaching or attaining that reward function. And the model learns that entire process by doing this, that is by reasoning. So the researchers at DeepSeek actually did not expect this at all. This was an aha moment for the model as well as for us when we saw this. And this was the first time they showed that this can be a completely separate method itself of inducing reasoning in a model. So that is why we have added a separate category for pure reinforcement learning. Now, I would say this is one of the highlights or the best part of this course is we are going to use a very methodical approach to understand how DeepSeek R1 did this. And for this, we have developed a technique which is called as the CMB technique. So let's understand what this technique is. The C in the CMB stands for classical reinforcement learning. So we are going to understand reinforcement learning from the complete basics from scratch here. Unless you understand reinforcement learning, you will never be able to truly grasp the beauty of what we have seen before, the beauty of the aha moment, the power and the beauty of reinforcement learning. And for that, this book by Richard Sutton is going to be our bread and butter. This is one of the best books in RL that I have personally read. In fact, he has got a Turing Award last year for his contributions to RL. A wonderfully written book, and I encourage all of you to get an e-copy of this book. It is freely available online as well. So, classical RL is very important to understand. The approach that we are following is actually very similar to what you see in any sport. Let's take the example of cricket, for example. If there is a player which I want to coach and I am the coach of the player, then Before teaching the player any technique, I will first tell the player what were all the classical techniques which people used in the past 40, 50 years back. Then I will tell them what is the modern technique. And finally, I will actually teach them to play shots using the modern technique. That is exactly what we are going to do with this approach. So the first thing is the classical RL. The concepts that we'll cover here is what is RL, elements of RL, understanding agents, environment, rewards, returns, Markov decision processes, Markov property, value functions, optimal value functions, policy evaluation, policy iterations, policy and value iterations. Then we'll move on to Monte Carlo methods, temporal difference learning, and approximate solution methods. I want all of you to understand that we are not going to use any complicated maths for any of this. RL is very intuitive because all of us use reinforcement learning every single day of our life. So it comes very naturally to all of us. Okay, so the first part is classical RL. The second is the modern RL, where we'll cover trust region policy optimization. Then we'll go to proximal policy optimization. And finally, we'll go to GRPO, which is group relative policy optimization. This was the policy which actually led to that aha moment, by the way. One of the major breakthroughs in the LLM plus RL literature. Uh, and this policy is inspired from PPO in a way, but it's slightly different. So we are going to understand modern RL in complete detail. And then finally, we are going to build our own reasoning model using pure reinforcement learning. That is, we are going to convert an open source LLM into a reasoning model by using pure RL. So, for example, we'll take the model 5.4 with no reasoning before, and then we'll convert it with 5.4 into 5.4 with GRPO, that is with reasoning. This is a brilliant method actually where you can convert any open source model into a reasoning model. And I think that these people at Fractal Analytics are going to use one of these techniques which I'm going to explain later as well. So once you understand this, you'll also understand how these people are converting any existing foundational models into a large reasoning model, for example. Okay, I hope all of you are with me up until this stage. If you want to revise anything, just go back, revise the concepts, and come back to method number three. Okay, so method number three is called as supervised fine tuning and reinforcement learning. Now, people think that OpenAI's O1 model was most likely made using this method. They have not and they will not release the architecture of O1, but it is most likely made using this method. And this method is what DeepSeek R1 also finally uses. So, in the literature, this is called as a blueprint for building reasoning models. This is the blueprint to build a very robust and best reasoning model. And these people are definitely going to use this technique, in my opinion, whenever they are building an LRM. Now, what are we going to cover here in this course? Uh, DeepSeek R1 actually have released this entire blueprint, which was kept secret by OpenAI before, but it's like the secret is out of the closet now. And yeah, so we are going to uncover this secret, and this secret is the portion which is marked in red in this figure. We are going to understand the entire development process of DeepSeek R1, and it does look a bit complicated, but don't worry, everything is very simple to understand, and we are going to make sure that you understand these concepts from scratch. The last method that we are going to look at is a very, very interesting method. It's called as pure supervised fine tuning and distillation. What does it mean? Okay, maybe I've heard of distillation before in the science context. You might be thinking, let's look at distillation. What is distillation? It's the process of separating the components of a liquid mixture through some evaporation and condensation. But why use it in the context of reasoning models, what does it really mean? So this is what we mean by distillation in this context. What we are essentially doing is that we are taking a large model, a large language model with a huge set of parameters. Imagine this to be something like, let's say, deep sea carbon, which has reasoning capabilities. Now, what we do is that we take this model and we generate a set of input output pairs. What are input output pairs? Maybe you give a bunch of 500 questions and then you get a bunch of 500 answers. What are these questions like? Maybe solving a puzzle, or asking questions like, if Roger has 5 tennis balls, he buys 2 cans of 3 tennis balls each, what is the correct answer? How many balls he has now? And in the output you give the entire reasoning with the correct answer. This is what I call my input output pairs. And another way of naming it is supervised fine tuned data. But forget about this convention now. Until you understand this concept, it is perfectly fine. Now, what we do is we take this data as an input and we give it to a small model which has zero reasoning capabilities right now. Let's take an example of Quen model, or maybe Phi model from Microsoft. All of these models, they are they are very small models with not a large set of parameters, and they are not reasoning models at all. So what you do is you take this input output pair of data and you fine tune this small model on that data, and then what you get is that finally you get the small model which has reasoning capabilities. So it's almost like, this is Popeye. Initially, Popeye is like a small model without reasoning capability. Then the spinach is like the data set from the large model with reasoning capability, and finally you get a small model with reasoning capability. This is, don't give this example in any interview, it is for your own understanding. But this was also shown in the deep sea carbon technical report. It's a wonderful process, and we are going to actually build our own reasoning model using the process of distillation, which is called as Sky T1 open source reasoning AI model. There is a popular GitHub repo which is available on this subject and with this name, and we are going to build it from scratch. So to summarize, we cover the following four methods: inference time compute scaling, pure RL, supervised fine tuning and reinforcement learning, and pure supervised fine tuning and distillation. And then these two are going to be, they will have hands on, where we will see how to build a, provide reasoning to a model using pure RL, and here we will uh, use the process of distillation to provide reasoning to a model. Okay, so this brings me to the end of the first lecture. I hope you understood all of it, and through this course, we are going to embark on a journey together where we are going to understand how to give reasoning to a large language model. I want all of you to stay very dedicated through all the lectures in this course. What we have seen is that in the initial lecture, students are very excited, but then slowly the excitement drops off. I assure you that if you stay excited and proactive in all the lectures of this course, you will acquire skill sets which will be very relevant to the requirements currently in the industry. So thank you very much, everyone. It gives me great pleasure to talk to all of you, and I am very excited for my first course. I am hoping to uh, follow my teaching style very rigorously, and make sure you all of you have a lot of fun during this course. Thank you very much.